Welcome to our 2022 Business Analytics Distinguished Speaker event. My name is Renu Ramnarayan, and I'm a faculty member in the Computing and Decision Sciences Department at the Stillman School of Business, where our Business Analytics program is housed. This evening, we're delighted to host Dr. Andreas Oranje from ETS, Educational Testing Services. Andreas has an MBA and a PhD from the University of Amsterdam and an MBA from the University of North Carolina at Chapel Hill.
That's so close.
At ETS, he is the VP of Assessment and Learning Technology, Research and Development. He and his division are responsible for developing all of ETS's assessments, products, capabilities, and service portfolio through the Artificial Intelligence Research Labs unit. This evening, Andreas will talk about evidence-centered design for business analytics. Behavioral and business analytics are increasingly becoming intertwined, especially as we carry multiple sensors with us, often day and night, that are always on. So going well beyond observable facts, approaches are quickly taking over to make the next leap in predicting behavior and therefore business outcomes. Andreas will introduce the approach and provide some practical examples. Before I hand it over to Andreas, I want to inform you all that this meeting is being recorded. All of your mics and cameras have been muted. We welcome all your questions and comments, both the in-person audience and the online audience. Please drop them in chat, and Andreas will answer them after his presentation. So without further ado, let's give Andreas a warm Seton Hall Pirates welcome.
Thank you very much. I don't remember signing anywhere that I was going to answer questions as well, but I was just talking and then we'll just see where we end up. But I'm very happy to be here. I've been involved with the Stillman School for about a year and a half, 2 years now as an advisory board member, and I'm always very happy to be on any campus. I mean, in fact, I just left campus a few months ago myself for that MBA, so I know how you feel. Okay, so whenever I hear an introduction like that, I always get very worried because ETS is sort of like the tax collector of education, right? Nobody wants to take a test. Fewer people even want to administer a test, but everybody always wants to hear the score. So there we are, and having a business. So to introduce, and please, if anyone online can sort of drop in the chat if you can't hear me, then I can maybe adjust volume. But if everything is good, don't do anything, and we'll keep it going.
I'll monitor the chat.
Perfect, thank you. So everybody here must at least once have heard the story of the drunkard who is outside the bar, and there's a light there, and he's looking for his keys. And there's this cop walking by, and he says, like, well, you know, what are you looking? What are you doing? Well, I'm looking for my keys. And the cop was like, well, did you lose them there? He said, no, I lost them in the park. He's like, well, why are you looking here? Well, because this is where the light is. And often that is used as a metaphor for bias in observations, right? And if you think about analytics and data sciences, it is sort of like we always look where the light is, but that's not necessarily where the thing is that we're looking for. But it also really symbolizes the tension between experimentation and discovery and confirmation. And that's really what tonight is about. How do we bridge that gap in an analytics way, and what can we do to not just make the light a little brighter and a little bigger, but also have some flashlights and searchlights out for the things that we're looking for. Because in a business analytics sense, you're always looking for regular patterns to drive, you know, decisions such as, you know, do I order the next thing? Do I, you know, throw a nudge over Instagram? Do I do another marketing campaign? Things like that. But you're also trying to look at, hey, there's something interesting going on here that may be giving me a competitive advantage, and that can be not under that lamp. He can be in the dark. Now, of course, the end of the story is that the cop was very happy that the guy couldn't find his keys because nobody wants him to drive home in that state. But I think it's a very important piece. So I want to basically show what does this experimentation, discovery versus confirmation have to do with business analytics, and how do we solve that issue that we actually can start to look in places where the light doesn't shine. All right, so little table of contents. I want to talk a little bit about my understanding of business analytics, and just knowing that not everybody has the same understanding of that. Then I want to talk a lot about inferential distance, and it's a little bit theoretical, but I'm a psychologist. I come from psychology. The MBA was just for the fun of it, and so I want to go back to reasoning and how we create sort of that chain of evidence. So then we have an inferential chain of reasoning, evidence-centered design. I want to introduce that, what that has to do with business analytics, and then talk about some tools that you can use to bridge that gap. And then I'll have a summary. So that's sort of what it looks like for tonight. I plan to go maybe about half an hour and then leave half an hour for questions, but by all means, ask away, interrupt me. I would rather have that than that you wait patiently, silently till the end, and then we have moved on, and it may not be as catching anymore. So please, anytime, just call out. So to me, business analytics is at the very core. It's about gaining insights from data to make better business decisions. That's what you're in the end trying to do. You're trying to get insights. And we have lots of stuff to work with, right? We have wonderful technology. We have SQL. We can learn Python. We can learn R. I'm sure everybody here takes a course, at least one of those. We can do Power BI. We can do Tableau and all so on. And we have lots of great methods, right? We can talk about distributions. We can talk about, prediction. We can do something with machine learning, see if we can use that in new cases, train on old cases. We can talk forever about data lakes, data warehouses, hybrid data lake houses, all cool stuff. And we have lots of data generating applications. The places that generate the kind of data that we're interested in, that we want to analyze, that we want to make predictions about, that we want to use to make smart business decisions. But none of those help us with insights. They're only still the part of the data and how we wrangle the data, how we collect the data, how we organize the data, what we can maybe apply to the data. But in the end, the gold is in the insights that we create. And that's really what this is all about. So how can we sort of take that toolbox and create insights that can help us drive decisions? So insights are where you find those keys and you can open the door. Unless you're drunk, then please don't. But it's not where you, it is not just applying big tools to, whatever data comes in. A lot of companies have pretty sophisticated data warehouses. Things come in, you can get in there, you write your SQL scripts, you can do all those things, but that's not where, as a data scientist or as a data analyst, your value is. That's just the mechanics. It's about how do I do the reasoning and how do I create the understanding of the data in order to make good decisions. And it turns out, and we'll get there, is that you have to be willing to do fairly qualitative stuff. In the end, it's about just pick up the phone and start talking to people, but we'll get there. So let me get into the idea of inferential distance. So and I have a few slides on this and a picture later that makes it maybe more clear. But let me go to my day-to-day business. I was trained as a psychometrician, and then got into assessment and education, and that's where I work now. And one of the things is we do remote proctoring, right? People want to take the GRE or the TOEFL. I mean, most of you probably took that at some point in your life, or maybe an SAT or an ACT. And, especially with COVID, but even before that, we had this idea of remote proctoring. You go in online, you open your laptop, and there's someone there who is going to look at you and make sure that you're not cheating, that you're not doing all kinds of things that are not, showing your true merit and your true ability. So what we need to do then is we need to predict the demand of the number of proctors that we need to hire. So suppose that one proctor can watch 6 monitors at the same time. Then you know, okay, if I have 600 people who are going to take the test, I need 100 proctors doing that for, between 12 and 2 a.m., Greenwich time, wherever in the world. And so we need to not just predict how many students we are signing up for any time, any test window. We also have to predict how many proctors are available in a certain geography, unless people want to wake up at 3 a.m. and proctor, and they do. But you basically have to predict both of those things and get them in sync. And we look at a lot of sources to do this problem. So you can look at how many people took the test last year. So just historical demand, always very easy. We can look at trends in student preferences. We can check Twitter. There's lots of Twitter stream where people talk about, hey, I'm going to take a TOEFL, or I hate ETS, evil empire, all those kind of things. We can look at test prep program data, because a lot of students come through a test prep into our test. And so we can kind of predict, okay, so many people went into this test prep program at this and this place. So we know that at least 10 of them will show up, 3 months later, taking actually the test. And things like that, success of acquisition, demographics, there's like a lot of things that you can do there. And then on the proctor side, we look at, things like unemployment, in a certain area. If there's more unemployment, you can probably get more proctors to more easily sign up. Just the workforce level in any geography, can we do we know what kind of education they have? And suppose as a proctor, you need at least 2 years of college degree or something like that. Then we can sort of figure that out. You can look at pay comparison, competitiveness, competitors that are also doing this kind of stuff, turnover data. Yeah, if I already know that at the end of the day, 20% of my proctors quit because they hate it or whatever, I already know I need to have at least 24% more proctors than I started with, and so on. But now let's just take previous year demand, and if we just look at that, we make so many assumptions to get to the point of making some kind of claim that we can predict how many proctors sign up, how many students sign up, etc. So questions you can ask: did I get the correct and complete database from last year? Whatever analyst was there last year, did they know what they were doing? Did we capture all the demand from last year? Maybe we only captured it at a few test centers, and so we actually don't know. Is demand actually stable year over year? Through COVID, demand plummeted, and then it went back up, and then it plummeted, and then it went back up. Are all the labels in my database correct? Right? Maybe someone switched labels, all stuff that happens. Am I actually analyzing the right variables? Even if the labels are correct, there may be some missing key variables that I just don't know about. Did I do my analysis correct? Am I interpreting it correctly? Do I reach the right conclusion? Because maybe the analysis is correct, I'm sort of understanding what I'm seeing, but maybe that's actually not behavioral relevant to what students actually do, because they end up flying somewhere else and taking the test somewhere else, even though I think they're going to flow into my test center here. And so there's all these things that we make assumptions about, and we don't always think about that. And so when you are trying to make a claim about this analysis and this set of variables to some business decision you want to make here, including how many people am I going to hire, you're making all these steps, and we often make them very subconsciously, and we just do that.
Actually, what would help me understand what you're talking about, because you're talking about so many students taking these exams, is your data normal? Is it, right? Do you make that assumption, or is it totally not normal at all?
Yeah, it is not normal. It is actually more like survival data. It's like Poisson distributed data. So it's sort of like you have a certain certainty of people showing up, and then there's sort of that survival that turns over, and then it's a long tail, and that makes it so hard to predict how many people actually show up, because that tail really can mess with you. So the act of even building an application. So suppose that you have an application that creates, data to get the registration. Just an application, just a website with registration. Just creating that application, and the choices that you make in what data you capture, which variables you go after, which clicks a student or a test taker, potential test taker makes, they're all part of the inferences that you're making about your data. And you have to really think that through in order to create true value from your data. And the more of those inferences you make, and the more steps you're making subconsciously or consciously, the larger your inferential distance is. And the larger that distance is, the more likely that you're wrong. And the more likely you're wrong, the more likely you're making poor business decisions, and you end up, either leaving money on the table, or you're ending up, losing money because, you end up with a test center that is completely empty, nobody showed up, and the next test center in the next county over is stuffed, and you had to turn away like 300 people who could have paid for your test. And that's like, $100,000 out the door, because yes, those tests are that expensive. So the distance is never zero, right? Because you always, like, this is the basic of human reasoning. I always argue that about 80% of our economy these days is human reasoning, and 20% is probably manufacturing and actually making goods. But since goods are so easy to make these days, and so and the chain is so efficient, we're really spending 80% of our time in reasoning, whether it's in courts, or whether it's in in school, or whether it is in services. So the distance is never zero, because it's always an exercise in reasoning. But the distance can be extraordinarily long when we only look under the lamppost and we're actually not having that flashlight shining around. So one way to explain this is actually goes back to Plato, right? 1000 before Christ, something like that. The allegory of the cave, and the allegory of the cave, for those with classical education, gives you maybe some trauma. I had to read that stuff a long time ago in Greek, and basically it is the idea that humans are in a cave, and the world is projected over their heads onto the wall of the cave, and that's what you see. You never get the real truth. And so what happens is, when you have variables and data that you are trying to capture and make decisions based on, is that you have maybe this phenomenon, which is like this nice burning sun in the middle. But by selecting parts of the data, selecting parts of the information that you're getting, you're already putting a big filter on maybe only capturing 10% of what's really going on. And then you process this data, and then you put another filter on it. And then you let that data go a little bit through various filters, databases, things like that. And then finally you observe something. And that's the idea of that the inferential distance can be super long, and you need to really think about how to deal with that. Right, it doesn't want to. Let's see if I can get beyond this slide. It's so impressed with this slide. Oh, there we go. All right, let me go back where I was. All right, and so that takes me to the main topic, and also the main technique that I want to share with you, and hopefully convince you to adopt this in your career as data scientist or business analyst, or just becoming the smart people that you are. And it is about how do we reduce that inferential distance, right? How do we make it as small as possible? And it starts with a discipline about reasoning. And so we often talk about the inferential chain of reasoning. It is all the inference we make to go from one piece of data to some business decision we make at the end. And so one way and one framework that has been used a lot in assessment, but I think is much more generally applicable, is evidence-centered design. So design for evidence. And it comes from Bob Mislaffy. He started this in 1993, and there's tons and tons of literature on this, and I'm happy to share with that, or connect you with Bob. He's a great guy, and I've worked with him a lot. And it is really the most widely used inferential chain of reasoning. And it consists of 3 models. And those 3 models we're gonna then in the next few slides apply to a business environment. So on the left side, you have what's called the student model, and that's really your theory. That is what you think is going on in a student's head. Okay, and so it's if we're talking about something like fractions, it could be about, okay, what are the building blocks that you need? What are the cognitive processes that you need to go through to solve a fraction of, 2 whole numbers under 10 or something like that. Then in the middle, you have your evidence model. And your evidence model is how do you go from this ability to solve fractions, that's your endpoint, that's the inference you want to make, that's the claim you want to make. How do you have the right steps in terms of the statistical analysis that you do on that data and the kind of variables that you transform and that you process and that you do things with in order to make an inference about the student model. And then at the very right side is how do you collect the data, the task model? What are the pieces of data that you create? And in assessment, it's often what kind of items do you create to make an inference about if someone can do fractions. Now, with fractions, it's pretty simple, right? You give a few fraction items. You then decide to score those fractions into right, wrongs. Then you say like, okay, if you have at least 8 wrongs or 8 rights and less than 2 wrongs or whatever, I'm going to say that's my statistical analysis. I'm just going to sum it up or average it. And then I make the inference that you can do fractions. And then I give you a pass score and you go on. That's a very simple model. When it comes to something like a concept like reasoning, are you someone who's good at reasoning? Or are you good at presenting? Do you have presenting skills? Are you, do you smile? Do you, tell some jokes? Are you, walk around? Do you move around? Do you keep people's attention? Or do you end up with people just, in their email or on text or whatever? That's a much harder inference to make. And so your inferential distance and the kind of things that you have to say becomes much harder. Now in business, you have the exact same problem. If you want to make an inference about whether someone bought, the latest pair of slippers, you just go to Amazon and you find out, okay, did people click on the yes or no button when they bought something and it got shipped and they didn't send it back, and you now know how many people bought slippers. Very easy inference. You don't need any machine learning for that. But if you want to, for example, decide whether this was a good M&A, whether you want an acquisition of some startup that is very unique, you have no comparables and things like that. Now you're making a huge inferential distance, and there's a lot of variables that you need to start thinking about and bring together into that student model. So translating that to business analytics and not using the 1993 picture anymore, because we can do better, but for nostalgia, I felt, we had to have the old picture out there. Instead of student model, you really have a user model or a business model. That's really what this is about. It's about the customer or user needs and your theory of what you think is going on in the heads of customers. For example, if it's a sales thing, how many customers will, be, excited about your influencer Instagram campaign, right? And you have some idea about it. And now you want to find out, okay, how do I find out whether that campaign was successful or not? And you want to set up, okay, what is my campaign going to look like to make that inference that my campaign is successful and that more people will buy my brand of slippers. In our case, it's again about test centers. So here you have, how many test center seats do I need to open on a certain time? And that is my business model, right? That's my business use. And then from an evidence model, it's sort of this classic news vendor model, right? And that's why I said it's a Poisson distribution. It's sort of your classic news vendor model. Everybody probably knows that from finance classes. And it's, sort of, you can add maybe a seasonality measure. You can maybe put something like a trends indicator, some competitor behavior. And then on the right side, instead of a task model, it's really an application model, your registration system, or the system that you use for your supply chain, right? All the things that go wrong, and you want to predict when things go wrong, when things break, etc. And so there you find out, okay, what is the what are the variables that I put in there that I'm going to monitor and that I'm going to bring into my evidence model, make some inferences about towards that theory about whether people will buy something or whether people will show up at the test center or not. And so there's lots of stuff there that you can do. You know, it's registration, website and data, payment system, cancellation data, web scraping of competition, pricing, promotions. There's all these things that you can basically use in that application side in order to then make inferences about, is someone going to show up at my test center or not? Are they going to ask for a refund? And do I need to open a second test center or a second test date in order to capture all the value that's there? Okay, so from there, I want to then move to sort of what this means and why this is so important. Building evidence-centered designs is very tedious, right? I'm talking about all these models that you have to set up, and if you're just looking at, you know, how many slippers did I sell, it's probably not that worthwhile. But as you create more complex businesses, and I think that's where, as sort of basic businesses are completely commoditized. I mean, Amazon has basically commoditized any basic business at this point, where you are not making that many more choices yourself. You are going to work on much more complex business problems. And so the tedious work that comes with building these models is actually going to pay off. And what you're really doing is you're piecing together lots of, you know, shards of evidence and making inferences that together then lead to that more comprehensive model. And it's really about balancing, you know, not waiting 3 years trying to build models so you can make that one decision, but it's like that on the fly. How can I start with something I kind of believe in and then continuously to update and build models? And so when you set up your applications, or when you work for someone who has sort of, say, a front store or something like that, it's not just about how can I get the data from here to make a decision, but it's also how can I already put in improvement data that's going to help me make better models in the future, because that invests in the longer term. So you basically have to learn to apply some kind of risk factor to your models and say, like, you know, I know enough to do this, but I don't know enough to do all these other things. And so if I have 3 competing models, I may lean a little bit more on this one and be less on that one. So for example, you know, you're in an M&A situation. I talked about that before a minute ago. And you may be able to get a pretty decent prediction of future cash flows. So you know that this company is going to throw off $3 million a year just from the cash flows, and you kind of see that it's going to go up and up and up, and then it's kind of stabilizes. It has maybe 8% growth for 5 or 6 years, and then it's maybe levels off to more sort of the economy's growth, which God knows how to predict that these days, but there it is. But you may not have any comparables to work with. So you have no idea what other companies paid for this kind of business anywhere else. And so your price determination may be at a very low end, and you're putting a lot of stock in the cash flows, but maybe not so much in the comparables. And so you need to weigh those things, and you put a smaller weight on the decision that you in the end make. But it's also that the stochastic nature of these stochastic models, right, of these statistical models that we were just talking about, these Poisson distributions, while they are often seen as a problem, they're actually your ally in this case, because they help you de-risk a little bit by applying a lot of different models and making those comparisons. So I think often people talk about sort of the issues with the uncertainty and the volatility. And I think as long as you can do this at a scale, you can actually, as you build these models, you can actually make that your ally. It's highly iterative. So when there's 3 models here, you're constantly moving back and forth between those. But it's really about the discipline of, yes, I have all this data here, but if I want to make this inference here about business models or about business goals, about customer needs, I constantly have to say, am I really collecting the right data? Am I really making the right kind of rules and analysis to make that choice? And then it's often very easy to say, like, okay, this is the data I have. But very often the data you have is actually not good enough to make your inference at the very end. And so then it's like, then what do I do? How do I actually collect the right data? Let me go on. And so this is then about changing your mind shift from how do I analyze the data to how am I going to design the data for my needs. So the data I have is, the assumption is it's never going to be good enough. It is going to help you making some decisions, but how do you shift from designing my data and creating the data that I need and creating the setup that I need? And so the idea of ECD is to be in charge of the data that you demand. And so if you work somewhere and it's like, well, this is data I have, or you get, it's like, well, that's actually not the data I need to help you really propel. And so then you have to start, talking with web developers and telling them to do some other things. And so that gets me then to what I call building intentional user data footprints. And so user data footprints are essentially your core evidence, your core setup that you associate with a customer, a business, or with a ship that goes along the world in order to build the evidence of the inferences that you want to make. Okay, so it's about how do I set up that core piece of data that travels along with, say, a customer that I will use to make all these inferences. So, for example, I want to know if an advertising campaign is effective, right? And I'm using 3 channels. I pay Google to put me at the top of the search listing. I maybe do a few YouTube ads. I have these people that create YouTube videos, and I pay them a little bit to have my product in their videos, or they may talk about my video for 30 seconds. And then I may have some Instagram sponsored content, right? So my user data footprint now needs to have the full tracking from ad, click through to purchase, right? So I may say like, okay, there's an offer here and there's an ad there, and then I hope they click on it and they purchase it and all is good. But this is the easy stuff, and you already get this. But you don't really know that if someone saw the YouTube ad and they love the YouTuber and they buy anything that person wants, and they maybe followed your contracted IG influencer, but they may still have gone to your website directly and just ordered. And so you have no way of knowing. And so how do you really track your campaign's effectiveness beyond the click-through data? Because the click-through data is messy, and it's very easy to say like, okay, I'm just going to look at my click-through data. But this is about how am I really going to not just look under where the light is, under the lamppost, how I'm going to really look what I'm looking for and find out whether I'm maybe wasting a lot of money on YouTube ads. Maybe that's completely ineffective, but I just don't know. So the footprint needs to have some of these outcome variables. They are not unimportant, right? There's things like customer revenue, advertising exposure, spend, net promoter scores, all those kind of things. But you do need some general behavioral data in your footprint. So it's basically what journey did the user went through to get to your product, for example. Did they search these and these competitor websites first, and can you track that into their browsers, or maybe not? You may need some geolocation, some time, some device information, some payment method. And then there are the most important, I think, once you have all those basic things that, Adware and all those big companies just give you, it's about what are sort of specific behavioral variables that you can build into that evidence model, into that student model. And so this can get very detailed, but this is where you really need to start thinking about the user journey. Where are they going? What are they thinking? Why are they clicking on this? Why are they not clicking on that? And that, to me, is the real value of business analytics. When you go beyond the data that's already out there and start to really invest in understanding the user, the customer, etc.
These companies analyze this data from doing surveys at checkout. They ask you where you heard about the company.
Yeah. So how often do you take the survey?
I mean, when you're checking out, they ask you like,
Yeah.
Oh, where did you hear about the company from a friend or from a coworker,
Right.
from the internet?
So,
and you just click on what you know about.
So
I'll tend to ignore.
I'm the kind of person who's like, none of your business. or I'm checked out, I'm done, right? I don't want to answer five more questions. And so, and in a way that is the core problem of assessments too, right? People don't want to take assessments. People don't want to take yet another thing to tell you how great you are or not. Nobody wants to go. And so it's about what you design in how to interact with your shop. That data you get on everyone. The survey data, etc., you may get 10%, 5%, and it still doesn't get you into. Now, if you can call someone and really like pay them a lot of money to really sit with you through something, that's different. And I will get into that in a second, because it's a very powerful way to get sort of in the qualitative side of things. But surveys, you know, if you get 10% response, it's great, but it's not, like you don't get what you need generally. This is about really like starting to design your application to really understand your users, understand what's going on. There's lots of ways to do this. You know, often there's either like sort of heartbeat data, right? Every 5 seconds you get the state, or there's change data, every change. And you know, if you think about someone moving with their mouse over a screen, that can get pretty gnarly. But this is one of the things that you have to get into.
The art world, they're going to track your eyeballs.
Yes. Yes, they will.
Yes, they are.
We're going to make lots of money on that. And then all those variables need to be summarized through an analytic or statistical evidence model. That's your middle part, and that really then drives your decision making. So my point here is that start thinking about designing data as opposed to just using data and just taking the data for what it is. And so this is where you go beyond the spotlight or the light on the street, but where you start to shine a light and a searchlight. So, you know, while a lot of us are very comfortable with, you know, running your SQL, your Python, etc., insights are inherently personal. They're individual and personal. And so I think that a critical toolkit to reduce that inferential distance that I talked before about is actually qualitative user obsessed. That's a typical Amazon term, right? They always talk about their user obsessed. It's user obsessed research. It's about not just running these large data sets, but then go into get a few people that are your typical customers and do retrospective interviews. Let them run through their experience again and really follow them along one by one. Eye tracking, or the song about eyeballs, very powerful tool. Think aloud. Let someone go through it and just tell you aloud what they're thinking, what they're doing. Journey mapping. What steps did they take? What is their, where do they come from? Empathy maps. You know, what resonates, what doesn't resonate. Sentiment analysis, journaling. I mean, there's lots of things. But I think this is often very overlooked as we teach a lot of sort of quantitative methods. But this is where you really get your insights.
So would you comment on the separation between the cognitive data that we would get from an individual and the non-cognitive, i.e. behavioral data? You would have a psychology background.
Right. Yeah, so in a way you never get cognitive data because at some point someone needs to tell you something, right? And you're observing.
I'm gonna lie to you.
Right.
Yeah.
As behavior. And so in the end, observing how people go through something is so much more powerful than asking them what to do. But you also need to, there's an exploration and discovery part where you're trying to get out from under that street light. And so that's where you need to just ask people. Survey Monkey has this big ad now that says like, sometimes you just ask. And I think it's a great one. And of course, it's their business, right? They just want to do surveys for everyone. But sometimes you just need to ask and get to that. So I'm not going to spend a whole lot of time on this because I think that gets a little detailed, but I assume that this presentation will be available and you can sort of peruse that at your own convenience. But the idea is basically, I took an efficacy framework, what you usually use for things like product prototyping, and changed that into a validation framework for business analytics. And so you have your user model, business model, your evidence model, and your application model, ECD, is in there. And what this is about is that as you design your analyses, your business and analytics, you go from less rigorous claims to more rigorous claims. And the further you get to the right of the model, the bigger your inferential distance is. Because here, you just make some kind of claim about it, how you think things work in someone's head, but you're not yet validating that. The more you go into actually getting data, getting those models going, the bigger the claim is, because now you're talking about the whole chain. And you're trying to make basically a claim about the whole chain. And so here are essentially the big questions that you should be asking, and some of the ways and the methods underneath that you can use to ask those questions, and the kind of things that you should be doing. So for example, if you're thinking about representative samples in your analysis, are you doing qualitative evaluation of your pilot analyses, and make sure that you have, say, subgroup data, and that you have subgroup differences, and that you look at that. And so, again, I won't go through this because we'll be here for another hour, but I think I'll leave that. I'm happy to talk about it later, obviously. All right, so that brings me to the final thing. So ECD, evidence-centered design, is a general framework. It's not specific to assessment. It's a general framework for building that evidentiary chain of reasoning. And it's about a discipline around focus and targeting, not just analyses, but data collection as well. Don't be a victim of whatever data is there. Go get there, go get it out there, and take agency in the data that gets fed from the IT department, from the marketing department, from this user experience, customer experience folks. You have to go out there and get the data that you as a business analyst and as a decision maker in business require. Combine that discipline and that thinking ahead about how you design your data with this iterative, user-obsessed approach is, to me, really the holy grail of insights and doing good business analytics. It's about knowing what's going on, talking to people, and then applying that to your large-scale analyses. And that is really where you expand that radius under the light, and where you also have searchlights and flashlights shining in the dark. Reducing the inferential distance, design for data, not the other way around, and sometimes you just have to ask. So those are my lessons for tonight, and hope will be helpful in your careers and in your studies. Thank you.
Anyone? I just have one quick one. So you're presenting a model. Yep, an abstraction model. Do you have any feel for the metric on how you would validate the model itself? You implied that distance is reduced with the application of the model. So is there any gut feel for when you're moving in the positive direction or a reduced direction?
Yeah, no, it's
good.
Yeah. I hope everybody on the computer, I'll just turn this around. Maybe the microphone is more directional. So the question was of sort of how do you validate your analyses, and then how do you know that you're on the right path? And there's an enormous literature about this, of course. But it's really about triangulating and about this idea of test retest. So the idea of test retest is basically you test it in, say, a small set, and then you retest it in, say, n more sets, and you see if you get sort of similar results overall. So you can say do a K cross validation kind of approach, where you parcel your data up in 5 sets, and then you do that kind of stuff. The triangulation, I think, is much more interesting, and that's really where you say, like, okay, I have these variables, and I have some theories about how these variables should relate to each other. And so that kind of triangulation, and never be happy with just the one analysis. Always do sort of like, okay, if this is true, this definitely cannot be true, because students can either do this or that. And then you look in your data, and it turns out that they can do both. And then you either find out that, we have ignored the ozone layer for 20 years and there was a big hole in it, right? Or you actually find out something that can really, which is a true story, right? We ignored the ozone layer hole for 20 years because scientists thought it was an anomaly, and it couldn't even be true, and it was never exclude data like that. Or you end up with a really exciting finding that can drive a whole new business and a whole new way of capturing value.
So non-linear, multi-dimensional.
Yep.
Takeaway here.
Yep.
Thank you.
I mean, in reality, when you deal with executives, what usually happens is they ask a question or when they want to see some sort of validation of, they want an answer. And you go out, look at what data you have, and more than not, you don't have the right data. I'm sure you've dealt with that situation.
Yes.
How do you tell your executive that you want to use like an evidence-based approach? You know, it may not be answer that you need in the time frame you need it.
Yeah.
How are you dealing with that?
Yeah, or consultant, right? It's the same thing, and you have to try a customer and you want to tell. So first, you know, the good thing is that there's lots of, it's a very hot job market as a business analyst. So like bite me, right? If you don't have a next to me, there's 5 others who will pay me double. But I think in the end, it's about like the executive is in the end the one responsible who needs to make the decision, right? You can only be an advisor and either helpful or not. And so it's about being very clear about the risks they're taking, but they need to make the risk, right? Because it's their bonus on the line, their job on the line. It's not yours. I mean, unless but then you find another employer, right? But the point is that, you know, as an analyst, you're always an advisor, and not an executive needs to just sort of be okay. And so it's like, listen, this is what we have. It is not this, and this. So I would not make this big a decision where you're potentially losing $15 million over the next month based on these and these things. And I think this is how you should do this. But if this is all you want, I would probably make this decision. Good luck. And I told you so. But I think it is absolutely possible to help executives see the value to themselves of being more disciplined about this and seeing the kind of business opportunities that they can unlock by being more disciplined and being more rigorous about it. There are always going to be, you know, places where, you know, it's quarterly results, something needs to get clear out there. But I think the most places that are thoughtful about building a data shop and building an analytics department, which more and more places do, they absolutely value this kind of stuff and the rigor. So, yeah. If you're constantly being asked to do these things and without that, then time to look somewhere else, I would say. Not the right place.
So there's a question from chat here. This is from Rob White, one of our faculty members in our department.
Right.
Can you provide some anecdotes about how successful some models at ETS have been? For example, how good is ETS at predicting the number of proctors they will need? Or perhaps how much better are recent models than what was done previously? 100% better? How much of a practical difference is this?
Yeah, so it used to be just ask the local test center to open up, and then finding out on Twitter that 6,000 people couldn't register and they're extremely upset with us, etc. I'm not going to say that it's so much better now because we're still building this as well, right? We are not super sophisticated yet. I mean, I tell a great story and as if we're doing everything really wonderfully, but there's still big gaps. But at least we're getting now, COVID sort of set aside because that was a completely unpredictable world. But post that, we're at least getting to a point where we know, like, okay, there's huge, like, sort of big gaps of opportunity, especially in the Indian market, which is really booming right now, especially in parts of Southeast Asia, while China is still closed, where we are really ramping up test centers and so sort of are able to make, you know, get a lot of value out of that. And we were able to drive through that some volume growth of around 8% this year. So that's a little bit more specific, but of course, it's also, there's demographics, there's lots of other things going on. So I don't think you can always pinpoint it to that one event, but You know, I think we're getting there. It's absolutely better than just have the local test center trying to predict what's going on, because in a stable world, that's great. The world is just not very stable. Good question.
Hi, my name's Joe. Talked a little bit about, I guess, the different classes that we could be taking now. But I was kind of wondering, what do you think is the best entry point into business analytics? And like, how do you think we should prepare ourselves before going into the market?
Yeah, so I think that the best entry is still getting the basics that you wouldn't be able to get on a job or on yourself. So, you know, it takes a lot of discipline to learn, you know, financial accounting, for example. And so that's a class that's, you know, is better taken in a classroom than with a study book. I think the same is true for things like basic statistics courses, you know, just about distributions and things like that. They don't have to be super sophisticated, you know, it doesn't have to be advanced, you know, latent regression analysis, but just having a basic sense of the distributions, I think is more important than anything. I think, especially, you know, you guys are so young, like 4 years when you're out, like getting a good basis in machine learning. That's going to drive so much value and so much things will be done. And the value that you provide is like, there will be platforms, and AWS does this very well, where anyone with half a brain to run together can run lots of machine learning, where you provide value saying like, you know, this is not the right, like doing this, right? Bringing that in. I think the other thing that is really you know, important is basically learning your basic SQL, Python, etc. But not necessarily for the reason of coding it. There will be analysts and people all over the world who will code for you. It's about knowing where they went wrong in the code and being able to then say like, hey, this is a really poor inference, because from my conversations with my customer and from all these things, I know that this is not true. So you must have, you know, declared this way on the wrong way, or you must have concatenated this in a bad way.
Right out or join.
Yeah, exactly. So those would be the one, and then the other thing is just get a lot of experience with different places that apply this, right? Because that's where the substance and the application, you know, internships, things like that, I think are very important. I don't know if the faculty here has another view on that.
No, that was very good. And thank you. No, there's 100 jobs posted on their website right now, just to let you know.
Yep.
So, this is a hiring opportunity as well. Oh my God. Right.
Any other questions?
Questions? Okay, if not, you're right on time.
And if you think of any questions later, I don't know if my email is anywhere, but if not, it's AORANJE. So first letter, last name, ets.org, at ets.org. Email anytime, you know, I do answer email, so. Although, you know, if you can select.
Thank you. This was a fascinating talk. I'm sure everybody enjoyed it very, very much.